you're always going to copy the givens word for word. Now, a lot of people are tempted to interpret the given statement in when they write it down. Okay, but don't. I want you to copy it exactly as it appears. Okay, so angle 3 is supplementary to angle 1. That's the given. Okay, now, when you look at that, that tells you specific information. So you can interpret it in the next step, but don't interpret it when you write it down. You need to build everything and justify every different or change in the statements. Okay, so here you're looking to show that ABC is an isosceles triangle. An isosceles triangle means what?
The two bases are equal.
So the two segments, or these two legs AC and CB, have to be equal. Then we can say that the triangle, again, has two equal sides. So in order for us to show that two sides are equal, what are we going to need to show or prove? We're going to need to show that these base angles, 2 and 3, are equal, because sides opposite equal angles in a triangle are equal to each other. And so if we want to go through, we need to introduce all these elements, angles 3, 1, and 2. Well, we have angles 3 and 1 already introduced, so let's interpret that information. So what does it mean that angles 3 and 1 are supplementary? They add up to?
180.
Good. So if we say that angle 3 plus angle 1 equals 180, and that's based on the definition of supplementary. And that's what was provided for us. Okay, so we've turned that into an equation, and the equations allow us to manipulate things a little bit more easily. Okay, so we have angles 3 and 1. We still need to introduce angle 2. So what's the most specific piece of information we have about angle 2? Okay, so these are together forming a straight angle. So angle 1 and angle 2 add up to 180. Now, it is true that those are supplementary, but we can't justify them as being definition of supplementary. And there's another relationship that's even more specific than being supplementary that those two have. And what is that? Jen? Yeah, so by definition of linear pair, okay, we're able to say that because, again, they're not only supplementary, they're also adjacent angles, which makes them a linear pair. Okay, so now we've got all of the elements introduced that we're going to need, and you should start to see the relationship. We have two things that are set equal to the same thing. And so what do you know? When two things are equal to the same thing, they are equal to each other. So we can make the statement that angle 3 plus angle 1 is equivalent to angle 1 plus angle 2. And the reason for that was, again, two things equal to the same thing or equal to each other is called transitive property or substitution. Again, you are going to need to identify when something is just substitution and when it is transitive or substitution. Okay, so make sure you can distinguish those two. And now when we look at these two equations, we can manipulate them even further, because what do we know we can do to each side of this equation? Each side we can remove an angle 1, leaving angle 3 is equal to measure of angle 2. And when we removed it, what was that process? Okay. When you remove equals from equals, the remainders are equal is subtraction property. Okay, so now we finally, in all of these steps, are now able to show that angle 2 and 3 now are equal. Therefore, what do you know about the sides opposite those angles? Okay, so once you know base angles are equal, then you can say that the sides opposite them, AC and BC, are equal. And the justification, and again, this is in that section 5.1, the justification is sides opposite equal angles are equal. Okay, so now we know that these two sides are equal. And so the final step, and even though we now see, if you look at this, you see that it's an isosceles triangle, you have to specifically end with that statement, ABC is isosceles. And the justification is by definition of isosceles. Okay, so as simple as that is, and you could explain it really easily in words, it took 7 steps in order to demonstrate that in a formal proof.